Morning guys. So today I'm just going to run you through how do we go about calculating area of polygons, right? The polygons we're going to be looking at is a rectangle. I'm not going to do a square because it's quite simple. Parallelogram, a triangle, trapezium, a rhombus and a kite. I'll do those together because they have the same formula, and a circle and a semicircles. Obviously a semicircle is half of a circle. So that's what we're going to be doing today. So to start you off, let's look at a rectangle, right? Let's call it A, B, C, D, right? So how do we calculate area of this rectangle? First of all, area speaks about this space that the shape covers. That is what area is. It's the space that the object covers. And so how do I get the area of that space? I obviously need the length, right? And then I also need the breadth. And so the area of that rectangle will be equal to that length multiplied by that breadth. So you'll say length multiplied by breadth, and that's it, right? So that's example one on the rectangle. Then on the parallelogram is kind of like a rectangle, but it's slanted a little bit to the right or left. So obviously this one is slanted to the right. So how do we calculate area of that? I'll label it A, B, C, D, right? If we're looking at a parallelogram, we are interested in firstly the height of the parallelogram, right? So the height is the distance from the base to the top. That is the height, right? And we're also interested in the base, the distance of the base. So area of a parallelogram will be equal to the height multiplied by the base. So take note, it's not this distance here, but rather it's the perpendicular height. It makes a right angle with your base. So it's the distance from that base to the top of your line. You can write this height right there. You can draw it wherever, but it's still the same height as long as it makes a right angle there. You got what I mean? So that's how you calculate area of a parallelogram. So let me write parallelogram here. And this is rectangle, right? So let's move on to a triangle. A triangle the area of a triangle, let's take a right angle triangle where no, not a right angle triangle, an equilateral triangle where all these sides are equal. The area of that triangle, you'll obviously need the height of the triangle, right? Obviously the height makes a perpendicular, it makes a 90-degree angle there with our base, and you're going to need the base of the triangle. And so the area is equal to half of the base multiplied by the height. It's the same if you take a right angle triangle. So that one will make a 90 degrees there. So this will be my height and that will be my base. So area of that is also still half base multiplied by height. But obviously, think about it. Sometimes in triangles, you might not be given the height. You might be given this guy. Let's call him X. And so how do I find the height? Given the base and the X value there, I need to use Pythagoras. So you apply Pythagoras, right? To find this height value, and you can just say the hypotenuse squared, the X value squared, is equal to the height squared plus the base squared. You get what I mean? So I call the hypotenuse X, and that's my height, and that's my base. So you need to apply this to find either one of those sides so that you can find area with it, right? So I've done those three: rectangle, parallelogram, and triangle. It's quite straightforward. Let's look at the other ones we can do. Alright, then let's look at how do we calculate the area of a trapezium. And why do we need to calculate an area of a trapezium? So trapezium could look like this, right? Or it could look like this. That's still a trapezium, or obviously the other way around, right? So it could look like that, or it could look like this. So let's label the one at the top A, B, C, and D there, right? So what do we need to calculate area of a trapezium? We need the height, of the trapezium, right? We need the length of this AB. Let me call it the top, or let me call it A, right? We need that length, and we need the length of the base. Let me call this base, which is B, right? And so what is the formula? Area is equal to A plus B. You add the top, the length of the top, plus the length of the bottom, divided by 2. You divide those by 2, and then you multiply this by height. I'll say it again. You take the length of the top, which is A. You take the length of the base, which is B. You add those two. You divide them by 2. And then you multiply it by the height. Right? So that's the formula. So here, if I label this A, B, C, and D, that will be my A. This will be my B. And that will be my height, this distance here. Because it makes a 90-degree angle there, that is my height, right? So those are the only things I need. And so area of this trapezium is equal to A plus B divided by 2 multiplied by height, right? Trapezium, hope you guys understand this. And then moving on to the rhombus and the rhombus and kite. So for rhombus and kite, the important things we need here is we need to understand what is a diagonal. What is a diagonal? And as soon as we understand what a diagonal is, we can start working with this, right? So take a rhombus. A rhombus is just a normal square that is tilted, either to the left or to the right, right? So if I label that it's A, B, C, and D, right? What we are concerned with when we're calculating area is that we're concerned with the distance from A to D, right? I'll call that diagonal 1, diagonal 1 or diagonal A, and we're interested in the distance from C to B, this distance here from C to B, right? And I call that distance diagonal 2, right? And so how do we find area of that? Area of a rhombus is just half of diagonal 1 multiplied by diagonal 2. So that's how we find area. Just need to multiply the first diagonal, multiply it with the second diagonal, and take half of that. And that should give us area of a rhombus. So this is a rhombus. And on the other hand, a kite this is how a kite would look, right? Call this A, B, C, D, right? So here we're also interested in the diagonal, but obviously we're talking about the A to C diagonal. I'll call that diagonal 1. So this distance from A to C, right? And the distance from B to D, I'll call that diagonal 2. Diagonal 2. And so my area of kite will be half of diagonal 1 multiplied by diagonal 2. And that's it. This is how you calculate area of a trapezium. The two different kinds of trapezium you could get. Same formula. It's just that the height is different. We're talking about this height, and there the height is the one inside the object, the one that makes a right angle with your base there. And when we're talking about rhombus and kites, we need to start thinking about diagonals. One that goes from C to B, and the other one that goes from A to D. Call them diagonal 1, diagonal 2. You multiply them together, you half them, right? Kite as well, you do the same. It's just that now the diagonals that I'm referring to is A to C and B to D, right? So that's how you find area of a rhombus, kite, and a trapezium. So let's do the last one. How are we going to find area of a semicircle and a circle? So circles, if I have a circle like that. Circle, let's first talk about perimeter. If I want to know the distance around that circle, the distance, if I stand right here and I walk around that circle and I come back to that same point, the distance around that circle is also the circumference of that circle, or is known as the circumference of that circle. And how do you calculate this? The circumference of that circle is just 2 pi r. So you take whatever radius you have, right? You multiply it with pi and you multiply it by 2 for me to get the distance around that circle. So that's not area, that's perimeter. Area is equal to just pi r squared. So the radius, you need to square it and multiply it with pi, right? But sometimes you're given a circle where you're given the diameter instead. So now you need a relationship between diameter and radius. And the relationship between diameter and radius is that, let me write it in terms of radius. Radius is equal to half of diameter. So if you're given a circle where you're given this full line, which is the diameter, right? Then you just half that full line, and then you just find half of that, which is the radius, right? And so that's how you calculate for a circle. For a semicircle, remember, is just half of a circle. So now you look at the area of a circle, we're talking about half of that, then the area of a semicircle will therefore be half pi r squared. That's the area of a semicircle. I hope you guys are with me. You won't be asked to calculate perimeter of this, but if you ever are, then you just need to think about it. This distance from here to there is the diameter, right? The distance from there to there, from one end to the other, is the diameter. And this is just half of the circumference. Remember when we were talking about circumference, we said it's the distance from me to move from there all the way around back to there. But now imagine if I'm moving from there and I'm just stopping down here. That's what I have here. I'm moving from here and I just stopped there. So it will be half of circumference. So the perimeter of that, if you ever are asked, will just be the diameter plus half of 2 pi r, which is diameter plus pi r. You're never going to be asked that, but let's imagine a world where now you've grown, you need to calculate that. That's how you were going to calculate it. So this video was just an introduction into what do we need when we're working with area, like which values are we going to be multiplying, because sometimes your object or your shape or your polygon is going to be bombarded with units. Like it's just going to be, they're going to give you land, they're going to give you all these things. You just need to be able to identify the ones you need and only use the ones you need, right? So this was all of that. Thank you.